Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from summer 2023. This paper is worth 120 marks in total, and this is the 6th video of 6. It will focus on questions 21 to 23, which account for 18 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 21. An inverted cone is held in a stand, so we can see that here. The radius of the cone is 20 centimetres and the height of the cone is 50 centimetres, so 20 centimetres and 50 centimetres. Okay, Jake pours some water into this cone. When he stops, the radius of the surface of the water is 6 centimetres. The surface of the water is parallel to the base of the cone. This is important, that's helpful to us. Rhian then pours water into the cone until it's completely full. She pours the water at a rate of 1 litre per 10 seconds, so completely full. How many seconds does it take Rhian to fill the cone? Okay, so we would need to go to our formula list, guys. And on that formula list, it will tell you the volume of a cone. So it's 1/3 times pi times radius squared times height. Okay, so that's the volume of a cone. So we are working with the volume of a cone here. So, and it's similar shape. So we're dealing with the volume of a large cone, the full cone, when it's completely full. But we're also dealing with the volume of this smaller cone here for when Jake pours his water in. Okay, so it's similar shapes. And the reason why we can use similar shapes here is because it tells us that the surface of the water is parallel to the base. So that surface of the water is parallel. So these cones are similar. So I'm going to start by finding the volume of the big cone, the full cone. Okay, because it doesn't matter which way around we do this. So the full cone would be 1/3 times pi times the radius squared, which is 20, times the height, which is 50. So the volume of the full cone is 1/3 multiplied by pi multiplied by 20 squared multiplied by 50. So that is, I'm going to leave it in terms of pi just to make my life easier. So that is 20,000 over 3 pi. Okay. Now, I want to find the volume of the small cone, but what I don't know about the small cone is its height. Okay, I know its radius, but I don't know its height. This is where the similar shapes thing comes in. So I'm going to find the linear scale factor. So I can find the linear scale factor by dividing the radiuses. So 20 divided by 6 is 10 over 3. Okay, so 10 over 3 is my linear scale factor. So if I do the height of the larger cone divided by 10 over 3, then that will tell me the height of the smaller cone. Okay, so height of small cone equals 50 divided by 10 over 3. 50 divided by 10 over 3, which is 15. So the height of the smaller cone is 15 centimetres. Now I can find the volume of the smaller cone. Okay, so the volume of the small cone equals 1/3 multiplied by pi multiplied by 6 squared multiplied by 15, which is 1/3 multiplied by pi multiplied by 6 squared multiplied by 15, which is 180 pi. Now the reason why I've found both volumes is because when Rhian pours water into the cone until it's full, okay, she's only filling this bit of the cone, so I need to find out what the volume of that bit of the cone is so that I can then calculate how many seconds it takes her to fill it. So the way I'm going to find that, this is called a frustum, okay, and that's when you have a cone or a prism shape like this, and you take off a similar version from the top. So you take a smaller version from the bigger version, and this white area is the frustum. So to find the volume of the frustum, we do the total volume, subtract the smaller volume. So we're going to do 20,000 over 3 times pi, subtract our answer, which is 19460 pi over 3. Okay, that's centimetres cubed. So that's how much water Rianne pours in to fill the cone, because this is what Jake did, and then Rianne does the rest. So she pours that much water in. Okay, so we're dealing with centimetres cubed. 1 centimetre cubed is 1 milliliter. Okay, so we need to change that into litres. There are 1,000 milliliters in a litre, so we're gonna divide by 1,000. So when I divide that by 1,000, I get 973 over 150 pi litres. Okay, this is important. It's not my final answer, and I've made a mess of my work in here, but bear with me. So she pours water in at a rate of 1 litre per 10 seconds. So that's how many litres of water she pours in. So we're going to multiply that by 10. So when we multiply that by 10, remember we're leaving things on our calculator to make our life easier. We get 973 over 15 pi. But I want to know how much that is in seconds. So that's 203.7846435 seconds. Question 22a. The first 5 terms of a sequence are shown below. So 5, 8, 11, 14 and 17. Complete the term-to-term rule for this sequence. So they've given us sequence notation here. So T1, term 1 is 5. Tn plus 1, so the next term is the previous term, and then something happens to it. And this n is greater than or equal to 1. So the term numbers, so first term, second term, third term, fourth term, fifth term. Okay. So we need to find the term-to-term rule. So we're just going to see what's happening to this sequence. Now it's an increasing sequence because the numbers are getting bigger. To go from 5 to 8, we add 3. 8 to 11, we add 3. 11 to 14, we add 3. And 14 to 17, we add 3. So the term-to-term rule is to add 3 to the previous term. So I'm going to put plus 3 there. It's really important that you put the add. You can write the word add or put the symbol for add. Doesn't matter, but you can't just put 3. Because that would be this times 3, and that's not correct. What we're doing is adding 3 each time. Okay, part B. Show that x cubed subtract 2x subtract 5 equals 0 can be rearranged as x equals the square root of 2x add 5 over 8. So when we're dealing with iteration, because sequences are iterative, when we're dealing with iteration, the usual rules of rearrangement don't really apply, in terms of you can do it in whatever order you want. Okay, and it's because we're normally dealing with cubics or quadratics where we've got the variable appearing more than once. So what you need to do is spot what stayed the same or similar. So let's start off with, here we've got x cubed minus 2x minus 5 equals 0. Here we've got a 2x plus 5 here, so it's not a minus 2x minus 5, but it's a 2x plus 5. So that means that these terms have been moved over to the other side, because the inverse of subtract 2x subtract 5 is add 2x add 5. So let's start by doing that. So x cubed equals 2x plus 5. Okay, now look at what else has happened. Okay, we've then divided by x, and then we've square rooted. Well, we would square root if this was an x squared, so dividing by x makes sense. So let's divide by x. So x cubed divided by x is x squared, but then we have to divide this side by x. Okay, we're looking good here, guys, because what's inside the square root matches. Now we need to show that we would square root x squared to get x. So we would write it as 2x plus 5 over x. Okay, B part 2. Use the iterative formula. So the next solution is equal to this iterative formula. So it's 2 times the previous solution, add 5, all divided by the previous solution. And we're starting with a value of x equals 1. We're finding a solution to that equation correct to 1 decimal place. So this equation is this equation, which is the same formula. It's just been written with iterative notation. So our first solution is x1 equals 2. So to get our second solution, we substitute that value in wherever we can see xn. Okay, so the next solution is the square root of 2 times our previous value plus 5 divided by our previous value. And what I'm going to do, I'm going to put that in a bracket because it helps me remember that that's where I need to substitute in the previous value. Okay, you might do it differently. And then I'm going to press equals, and then I'm going to write that as a decimal. So 2.121320344. I'm aiming for 1 decimal place, so I'm going to keep going a little bit longer because I want to see it all converging or diverging to the same 1 decimal place. Okay, so let's get the third value, but this time I've not deleted what's in my calculator. So what I'm going to go back and do is to use, not delete anything that's on my calculator. So what I'm going to do is I'm going to type that formula in again. So it's 2 times my answer, my previous solution that's still in my calculator, plus 5 over my answer. So let's press equal. So that gets us to 2.087348223. Okay, I'm going to go again, but because I'm using answer here, I can just press equals. And this is the point where our life gets pretty easy with iteration questions. So let's get x to the power of 5, so 2.094017159. Now we're aiming for 1 decimal place. So what we're looking for is when this starts to look the same, okay, starts to repeat, but obviously these values on this side will make a difference potentially to round it. So I'm going to get my next value, which is 2.094696882. So you can see here 2.09, 2.09, 2.09. So I can quite confidently say that a solution to this equation would be x equals 2.1 to 1 decimal place, because even here 2.08 would be 2.1, 2.09, 2.1, 2.09, 2.1. I had to wait for this to be repeating really before I decided that it was 2.1. But I'm going to go with that, x equals 2.1. Question 23. In this question, x and y are horizontal and vertical distances in metres. An engineer designs a tunnel. He models the uniform cross-section of this tunnel using the graph shown in the diagram. So this is the cross-section of the tunnel. And actually it does look like a tunnel. If you've ever driven through a tunnel in any kind of vehicle, that's what a tunnel entrance would look like. So the tunnel is 50 metres long and it will cost £250 per metres cubed to excavate it. So we're using the graph with 4 vertical strips of equal width to calculate an estimate of the total cost of excavating this tunnel. So this, guys, is working with the trapezium rule. Okay, so we're going to estimate the area of this cross section of the tunnel to start off with. Now I'm going to use a pen because I want you to be able to nice and clearly see my lines, but I suggest that you potentially use a pencil because you don't want to have to rub out a load of lines or have a load of lines in pen and not make it clear to the examiner. So I want 4 strips of equal width. So I'm going to have 1, 2, 3, 4. So let's start with that. So we're going to draw lines up from each of those points. Okay, so we've got 1, 2, 3, 4 strips of equal width, but we are estimating, so we can't actually use the curve. We're going to form trapeziums here, guys. So the estimating part is the fact that that little gap between this edge of the trapezium and the curve is not going to be involved. But that's okay because it's an estimation. Okay, so we have 4 strips that are trapeziums. So we have A, B, C and D. So we're going to find the area of each of those. So remember the area of a trapezium. So let's find the area of A. So we do the parallel side. So this is 4 and this is 7. So we're going to do 4 plus 7 equals 11. And then we times it by the height, the distance between them, which is 3. 11 times 3 equals 33. And then we half it. So 33 divided by 2 is 16.5. Okay, so that's the area of that section. We're going to do the same for B. So the area of B. So parallel sides. So this is 7 plus 8. And then we're going to times it by the distance between them, which is 3. And then we're going to half it, which is 22.5. Let's do the area of C now. So C and B should be the same, but let's check. So it's 8 plus 7 times by 3. Yeah, so we can say that the area of C is 22.5. The reason why they should be the same is because this is a quadratic, this is a parabola, and they have a line of symmetry. So, but it's worth checking. And then I'm hoping that A and D are the same, but we'll find the area of A anyway, area of D anyway, just to be safe. So that would be 7 plus 4, 7 plus 4, times by 3, and then half it. So that is 16.5. So meters squared, meters squared, meters squared. So we're going to get the total area. So the total area, or the total estimated area of that cross section, is all of those added together. So total area equals 16.5 plus 22.5 plus 22.5 plus 16.5. Okay. Which is 78. So it's a total area of 78 meters squared. We're dealing with volume, so we need to find the volume of the tunnel so we can figure out the cost to excavate. So the tunnel's 50 meters long. So this is the cross section, the uniform cross section of the tunnel. So if it was a 3D shape, we would multiply by its length. So 78 times by 50 times by 50 is 3,900 meters cubed. Wonderful. That's a total volume. It costs £250 per meters cubed to excavate. So we're going to times that by 250 to find the total cost. And again, this is where not deleting things out of our calculator helps us a little bit with time and accuracy. So it should cost £975,000 to excavate that tunnel. So £975,000. And that's the end of the paper.